Example 8.9. So this time we are given the Z impedance value and it is asking to find the admittance, okay, using Smith chart. How to do that? Let me try to visualize it. Let's say this is our SWR circle and this center, and let's say this point is our Z normalized. Okay, so if we rotate this 180 degrees, this point will be our Y normalized. After that, we can easily find the Y, okay, admittance. So, first of all, what is our Z normalized? So, we just need to divide these values by RO value, okay, RO. But in the example, it is not given. If it is not given, we are taking it as 50 ohm. Okay. If you divide 95 by 50, let me divide on my phone. It is equal to 1.9. 1.9, the real value, plus J. What about imaginary part? It is okay. If you divide 20 by 50, it is 0.4. Okay, this is our Z normalized. We will find this on the Smith chart and we will rotate 180 degrees. So we will have our normalized admittance value. After that, we can find this. Now let's go to the Smith chart. 1.9 real value, which is this 1.9. Okay, going up because plus J, the imaginary part is plus, so we are using the upper side of the Smith chart. 0.4. Okay, this one. The intersection point will be our normalized Z impedance. Okay, here the intersection point. Okay, I will take this arrow. Okay, it's fine. So this is our Z normalized. Let me write Z normalized. I need to rotate this 180 degrees so we can find our Y normalized. For that, let me duplicate this one and zoom out a little. Okay, we need the intersection point with the SWR circle, so also let's take this one, make sure it is locked with and height to have not ellipse, to circle to have a circle. So let's go. A little more, we need to dimensions. Okay, let's say 4. Yeah, okay, this is good. So this is our SWR circle, this is our normalized Z, also the intersection point here, this is our normalized Y value, okay, here, this point. Now let's read the value. Y normalized, it is here, this line is 0.5, and a little more, 0.52 we can say. 0. Let me write here 0.52, and also we have imaginary part. I am putting minus j because this is bottom side, lower side of the symmetry chart, so the j values, imaginary values, will be negative. Okay, so where is it? Okay, this line is going. Let's see where it is going. Just traveling. Okay, 0.1. Let's say 0.1. Admittance normalized is equal to, I remember this part, 0.1. 0.1 minus j. I also remember it was minus j. What about 0.52? 0.52. Okay, we have our admittance, normalized admittance. Okay, but in the question it is asking admittance, not normalized one. Okay, it's quite simple. If if this was if if this were impedance, we would multiply, right? We would multiply all the value by RO, which is 50, to find the Z. If this were Z, Z normalized, we would multiply. But since admittance and impedance reverse of each other, so this time we need to divide. Okay, we need to divide these values by 50 by RO to find the uh, Y admittance. Okay, so I will divide 1.52 by 50. 0, 0, 1. Also 4 minus j. Now 0.1 divided by 50, it is 0, 0, 002. I'm using the touchpad, so it is being a little harder. Okay, this is admittance, but we can say 10.4 minus j 2 milli. Okay, evet. Not millisecond, of course. So this is our final value. Okay, the admittance. So that's it for this video. If you can check this example, I'm not sure. I think it's correct answer. I will check. If this is wrong, I won't publish the video. Okay, so that's it for this video. Thank you for watching. Have a good day.